Hi everyone, welcome to this new lecture of fluid mechanics. In this lecture, we'll discuss another flow measuring devices which is known as elbow meter, or it is called also pipe bend meter. So in our previous lecture already we have discussed regarding the rotameter and nozzle meter. So here we'll discuss about the elbow meter or pipe bend meter. For this, as the name is indicates elbow meter or pipe bend meter, we can draw a pipe like this. Okay, so this is the bending pipe is there, and another pipe also we need to draw like this. So little bit this is little bit yeah, we can keep some gap here. We can draw like this. Okay, and here it will be the pipe entry, you can keep like this, and here this may be entry or this may be entry, any one entry will be there. So here what I'll do, suppose this is the direction of flow in this zone, and this will be the outlet of this flow, will be out on the particular point, and we can draw the line on this. Now along with this, we need to draw another one section here, and here another one part, so that we can follow the Bernoulli's equation. And along with that, we need to connect a pipe bend meter or elbow meter like this. You can connect here and just give the dotted line here, and this one we need to connect like this. A differential manometer will be connected to measure the pressure difference. Yeah, like this. And here in this manometer we have mercury will be there, which will be give the pressure difference. Okay, so you can calculate the pressure difference in this point. Yeah. And this is the difference which is measured, that is X value actually. This is a differential manometer which is connected. Now here we need to connect, that means two pressure measurement points are there. Suppose this is one point and this is another point is there. Okay, this is one part and this is another part, suppose. Okay, so the liquid will be flows through this part, through this pipe bend. So I'll tell you what are the concepts are using on this and how it is to be measured. So this pipe bend or elbow meter, actually it is a, you can say 90-degree pipe bending, which is having two pressure positions, one pressure position 1 and pressure position 2, and one will be in the inside part, another will be at the outside part. So one pressure tapping will be inside part, another pressure tapping will be at the outside of the pipe. So these two things we need to be considered. And when the liquid is flowing, you can see when the liquid is flowing through the pipe, okay, in this round bend, at this round bend, you can say the bending, there is a free vertex condition will be developed. Okay, there is a free vertex will be developed. Okay, so there is a free vertex will be developed here, and due to this free vertex flow in this pipe bend, the pressure is going to increased. The pressure is going to be increased. Okay, and if you see, this pipe bend is there, and due to the pipe bend also, I can say you that at this position we have a centrifugal force which is going to act on that. Okay, the centrifugal force which is going to act. So when the fluid flows through the pipe bend, its force changes its direction. That means its direction is going to be changed. That means, see, normally if the pipe will be like straight, if the pipe is straight, it is going only straight direction. If it is going in the horizontal direction, it may be moving like this. Okay, but here it is different. Here we have a bending pipe. So in this bending pipe, that means the direction of this flow is going to be changed. It is direction from like vertical to, you can say, horizontal. And in this, and that is here there is a centrifugal force is going to create here. Here there is a centrifugal force going to be create here. Okay, and this change or this force causes the higher pressure on the outer side, or you can say there is a pressure which is going to be increased at the outer side. Okay, and what are the other effects are there? Now there will be a this is one region, and centrifugal force is one region, and fluid inertia. Fluid inertia is nothing but fluid inertia. That is nothing but when the fluid is changing its direction. So this fluid inertia is having a region. And next, Bernoulli's equation is going to be applied on this because we know that when there is a fluid flow is there, and the Bernoulli's equation is going to be applicable for the particular flow. Okay, so these are the three concepts are there which is applicable here. And the reading, as I told you, from the differential manometer, we can calculate the pressure head H value, and H value will be calculated from this differential manometer. And how to calculate this one? This is differential pressure head. So we can calculate based on the previously also we have discussed regarding the venturi meter and orifice meter calculation there. This is H equal to X into, it used to there like specific gravity of the heavy liquid and the specific gravity of the light liquid. This is the differential manometer to calculate in this pipe. Okay, now our aim is to identify the discharge through this pipe. Okay, discharge through the pipe. So we need to find out the Q value. We need to find out the Q value. We know that if you see, we know that Q equal to, we have discussed that the area into velocity. Okay, so here for this particular elbow meter, from this area into velocity, we can write, CD into area will be there, because coefficient of discharge need to be considered for this elbow meter, and that depends, that depends on the this radius of curvature. Okay, or we can say the axis bend. That means the pipe, how much angle it is bent, and what is the radius of the pipe. Both need to be considered. I'll tell that one. So here the equation can be written Q equal to CD into area into velocity point. We can write 2gh, root over of 2gh. This root over of 2gh already we have discussed regarding our Peter tube type. We have discussed velocity, how to calculate, that is root over of 2gh was there. Anyway, so in this equation, if you see, we have first one CD. CD is nothing but, as I told, this is coefficient of discharge. The coefficient of discharge, and the value will be coefficient of discharge, and the value will be vary from 0.56 to 0.88. Okay, and next is, as I told you, this coefficient of discharge depends on the discharge of elbow meter, and the depends on the ratio of R by capital R by small r. Okay, where this capital R is the radius of the axis bend. This means this bending, how much it is bent. So this is radius of axis of bend, and the small r is the nothing but the radius of that is pipe. Okay, and next is cross section area. As I told you, the cross section area of the pipe. So this one we can calculate by pi r square, and H, as I told you, this is a differential manometer head. So this is the differential pressure head H, and we can calculate by this formula. And X is the differential mercury level. Here you can see the mercury level. See, when the mercury level will be different, when there is a flow will be there, so the pressure will be here. The pressure difference will be there at this point, at this only curvature point. Okay, so how much pressure difference was there here, that will be measured in this differential manometer. So that will get a difference. So from that difference we can calculate the H value. Okay, so X is the differential mercury level, and in this Sg is there. So Sg is nothing but specific gravity of the heavy liquid or mercury, Sg. And similarly SF is the specific gravity of the liquid which is flowing through the pipe. It may be a water, it may be any liquid. Okay, so this is the concept of elbow meter or pipe bend meter. And few things are there regarding this, like some advantages are there, some disadvantages are there, and some applications also there. So I'll tell one by one. Advantages, what now we can say, this is the very cheapest device, cheapest or less cost, that also right, cheapest in price or cheapest device or less in cost, and simple to install, simple or easy to, simple to operate or easy to install, we can write. Okay, and next is we can read the pressure loss is very less, pressure loss is very less, and it can be used for any kind of fluids, applicable for all fluids. So these are some advantages are there. Along with that, some disadvantages also, let me tell you. Some disadvantages are there. So in the disadvantages we can write, there is a question mark on the accuracy point. There is a question mark on the accuracy. Okay, and the geometry you can see little bit complex is there. Here you can see this geometry part of this. So there is a complexity on the geometry. Complexity on the geometry. And one more point we can write regarding this. I can write one more point. Installation requirements. Installation requirements are there, and for that we require some skilled person for this. Okay, installation is easy, but for this installation purpose we require a skilled person for that. So along with that, some applications are there. Applications are most important, because without any application there is no use of the concept. So application we can use mostly in industrial case. In the industry also, different kind of industries are there. In the industrial or gases point, we can calculate, we can use this one. Mostly you can use this one, petroleum industry or chemical industry. And along with that, you can also use this like wastewater treatment plant. This can be used wastewater treatment plant. We can see, if you have seen the wastewater treatment plant, there mostly the pipes are in the bending condition which is there, and to measure the pressure in that particular point also we can identify there, and what is the discharge from this treatment plant also can be calculated by this. And along with that also we can use in the food and beverage plants. Food and beverage also you can use, and also you can use this for the energy and utilities. Energy and utilities. So these are the few different advantages and disadvantages and applications of this ergometer is there. And along with that, let me just recover this one, like how we have described and what is the working principle of this ergometer we have discussed. So it is very simple in design, you can see. So only the difference is we need to consider is in a bending condition. When the pipe is in the bending condition, and we need to just connect a elbow meter in this bending position only, and there one sensor you can say, or one point you can say, where you need to be it needs to be kept inside the pipe, another one is outside of that, and so that we can measure the inside what is the pressure level is there and outside what is the pressure is there, so that we can get a difference in that. And remaining all are very simple. This is the continuity equation is there, and Bernoulli's equation is going to be increased, going to be applied here, so that we can get the difference, what is the pressure and velocity, because velocity changed means your pressure will be also changed. And there is a centrifugal force which is acting on this point, okay, due to these changes its direction in the pipe. And full fluid inertia is nothing but when the fluid changes its direction, so it is to taken in the fluid inertia. So these are the 3 points. So I hope you understand this working of elbow meter. So if you're having any kind of query regarding this, you can give a comment on the comment box. Thank you all.